Alrighty. So let's start with some introductions. For those of you that haven't heard me speak before, my name is Federico Lucifredi. We all work at Red Hat. I am in the Ceph storage business unit in product management.
I'm Sebastian Hahn. I work as a Ceph engineer.
He's modest. He's one of the best gurus we have for Ceph on planet Earth today. Hi, everyone. My name is Sean Coyne. I've been with Red Hat for more than 5 years and been with OpenStack more than 5 years. And I've been doing product management for OpenStack forever. And this is a very close and dear topic to my heart. So if this is your first time you're hearing us in general, and you can look at YouTube and previous summits. So this is basically a continuous theme. We're doing in every release, we have new stuff coming up, right? And it's hard to catch up, so that's why we're here. All right?
All right. So, how to survive a major disaster? It turns out there are multiple definitions of this. So, in the sense of going full CIO on you for a few seconds, what's the problem? This is May 2015. This is an Apple data center in Mesa, Arizona. A nice bonfire is reported by the article in Data Center Dynamics. April, a year earlier, major fire at Gwancheon in South Korea. Yes, those are pieces of building falling off a Samsung SDS facility. And that is a helicopter dumping tons of water to douse an out-of-control fire. This event caused a global data service outage for users of some Samsung products, including tablets, smart TVs, and phones. And by far my favorite, shameless plug, if you read my book when it comes out next month, this gets top billing. February 28, 2017, an Amazon S3 service disruption in Northern Virginia brings down several parts of the internet. Impact reaches as far as Twitter and other major media properties. You know what this is. It's the S3 big outage last year. Notably, even Amazon's own service dashboard malfunctions as a result of a dependency on AWS S3, and the US East 1 region is reported as green during the outage. This was a human error. This was not a fire or war or anything strange. So it turns out you can still fat finger away a whole cloud if you have enough skill to do it. So my point here is that chances are that you have far fewer IT resources than any of these world-class players. And a lot of money is at stake if you're a service provider. The Lloyds of London estimated that an outage of 6 days at one of the major providers, actually of 3 to 6 days, they wanted to leave themselves some room, could generate $19 billion in economic losses. That's with a B. The financial and reputational cost of downtime can be simply enormous to any organization. And you know that stuff will happen. You need to be prepared. There is simply no way around it. So let's see how many types of disaster we manage to map for you. But be prepared for what? Let's begin by segmenting the problem. When most companies talk about disaster recovery, they're referring to backing up their data and how quickly they can restore it if something goes wrong. Their strategy depends on how much downtime their operations can tolerate, balanced against the cost of restoring full functionality and at what velocity. Let me impose some CIO speak on you for a second. A business's tolerance for data loss is codified by a recovery point objective and a recovery time objective. These are the targets a company sets for itself when it defines its recovery plan, its data protection plan properly, specifying how much data can be lost due to downtime and how quickly service must be restored. Those are the two metrics. High availability, disaster recovery, and fault tolerance are all related, but they are not the same thing. And one thing that we have learned giving variations of this talk over the years is that this is not universally clear. So let me be a little bit pedantic and hammer on that. On top of that, neither of those three things are a substitute for a backup. So This has been making the rounds of the storage community in the last 2 weeks. I got it from SJVN, who I haven't seen at this conference. He's one of my favorite sector columnists. I was unable to trace the actual origin, but it seems brilliant to me. The point, of course, is not to mix one thing with another. RAID is not backup. Backup is not HA. HA is not DR. You want to decide how much of each you need. What if you lost your data center completely in a catastrophe, but your users hardly noticed? That is the promise of DR, and it may not come cheap. How about if we settle for backups that actually can be restored? Cheaper and usually rather necessary if you like the idea of staying in business, but last year alone, there were 2 well-publicized cases that I'm not going to name out of mercy, of IT companies, not other industries, our very own, who couldn't restore their backups and had to admit it publicly. There are also some good news, however. Organizations who choose to deploy OpenStack together with Ceph storage usually note that these are inherently highly available solutions. So HA is part of the plan. There is no additional cost to HA once you deploy your cloud. So at least one you can check off for free once you move into the modern era of either public or private cloud. So let me hand it over to Seb, who will start dissecting how we can prevent the first of these undesirable outcomes.
All right.
If you want the clicker, it's here.
Oh, yeah, thank you. All right, so thanks, Federico. So as Federico mentioned, there is no way you can really predict all the things that could happen in your data center. So what we're going to do here is we're going to go through the state of the art, what's currently possible for OpenStack, and how we can prevent loss of data. So first and foremost, it might sound pretty common, but you really have to differentiate and segregate all of your data. So typically what you will have to do is to build different failure domains. This is already something you do when you build network, when you build compute, so you also have to do this for storage. Typically when you deploy Ceph, what is really recommended is at least to get 1 replica per rack. Obviously you can go really granular because Crush has this really thin-grained capability where you can basically create any root that represents a particular infrastructure of your data center. So you can go as granular as you want, room, pod, PDU, you basically name it and you can get it. So, but at least make sure you differentiate and you segregate all of your data through differently physical infrastructure. One extra step is to have different storage clusters. So this can be part of the same facility, the same data center. And if you go beyond that, another requirement is to basically have one cluster or different clusters spread across different geographical locations. What we have been having snapshots for years now, and in an OpenStack conception, this means several things. But what I really want to highlight for snapshots is that snapshots are not backups, and they will never be. Simply because when you do a backup, it means that you take a particular copy of a piece of data and you have to store it somewhere else. And this somewhere else is definitely a different storage entity. So if you use the same storage entity to perform what you might be calling backups, then you're really doing it wrong. Because if you lose this main storage entity, then you lose also your snapshots. So the snapshot, the way you should see it is just something really convenient to get a really point-in-time version of the data. Although this doesn't mean that you don't have to do it, but it's just for convenience. In OpenStack, what we call a snapshot can differ whether you use Nova or Cinder. So normally when you take a snapshot of an instance, then what you get is a new image being uploaded into Glance. So it's not really a snapshot, it's more like a full copy of a current instance. Although when you take a snapshot of a block device, then what you get is just a new snapshot. So then you get layering, sorry. And all of those capabilities from your storage backend, so in this case for Ceph. So the snapshots are just fast and convenient, but if you have to do snapshots, it's always strongly recommended to use a QEMU agent within your VMs. If you don't really do this, then you can't really make sure that the integrity and also the atomicity of the transaction is good. So in this example here, what you see is the interaction between the hypervisor and the guest, so the virtual machine. Typically what's going to happen and what's really recommended to do is to set up a hook within your virtual machine. And what's going to happen is when the user or the person responsible for the application and for maintaining it will basically call the snapshot. Then the QEMU hypervisor will just send out the request, go through the QEMU layers, and then it will be intercepted by the socket inside the VM, so by the QEMU guest agents. Then a lot of actions are going to happen. So first of all, we're going to freeze the file system, and then we will call a hook to, no, first, sorry. We call a hook, and then this hook will take a particular action. So if it's database server, then we just stop the server, and we freeze the file system, and then we take the snapshot at the block level. Once that's done, we unfreeze, and then we restart the service. And that's really the only way that you can get a really consistent snapshot for your application. And because when you do this, you really ensure that you have the application level, the file system level, and the block level, and you really have all of those layers, and you know what you did, which transaction you committed, and basically what the snapshot looks like. Then you have something that has been around for a couple of years now in Cinder. It's the Cinder Backup functionality. So this functionality basically allows you to create backups from any block devices that is attached to a particular instance. So what's going to happen is you just, first of all, create a full copy. And then once you create more and more backups of this particular block device, this will go incremental. So what's going to happen under the hood is that you will get a differential for each block that were not present. So we always resynchronize the delta. This works at different levels. This can be from Ceph to Ceph. This could be also to other backends. But naturally, we want to do it from Ceph to Ceph because you get this really efficient delta incremental-based synchronization. You can do this for Ceph pools, between Ceph pools, but it's not really recommended because once again, if you're doing this, then you're doing this into the main storage entity. So you always have to point that to a different storage entity, which in this case is a different Ceph cluster. If you want to go more granular, you could use third-party vendors, which are really good at scheduling backups and also restoring a particular file for your backup. So now we're going to dive into what's the real enabler when it comes to doing disaster recovery. So we're going to discuss a little bit the RBD mirroring feature. So the RBD mirroring feature came out like 2 years ago for the Ceph Joule release. So it has been around for 2 years now, and we have been really building new functionalities for each individual Ceph versions. So at the time, we released this new RBD Mirror daemon, which is responsible for synchronizing Ceph block devices from one cluster to another. It basically relies on two RBD features for the RBD images, which are the journaling, which means create a journal for that particular image. So the journal represents a log transaction of all the transactions that happen onto this particular block that we can later replay. So we can replay the transactions and then copy them over to a different cluster. Then we have the mirroring functionality, which can be enabled at different levels. The first one can be at the image level, or this could be at a pool level. We can say, okay, replicate all of the images that are part of this pool. The images have two different states, so they can be primary or non-primary. So yeah, it's pretty self-explanatory. At the beginning of the implementation, we had this one-on-one relationship between the clusters where you could only do replication from one cluster to another, but you could also do cross-replication. So if you have, in this case, we have the active cluster and the passive cluster, but you could replicate images from the active cluster to the passive cluster, but also images from the other cluster. So you can really enable this cross-replication. Then for Luminous, so the current Ceph release, that is almost a year old now, we continued to add more features to this daemon. So currently we can have multiple Ceph daemons, multiple RBD Mirror daemon, but they're not all active at the same time. So only a single one is responsible for doing the replication, and the other one are just basically waiting for, well, the first one to crash, and then they can take over, which is relatively easy because the only thing you have to do in this case is that you will just replay the log transaction for a particular image. So there is no data loss, and the journal keeps increasing, and then you just replay the transactions. So it's fairly straightforward. We added the ability to do this one-to-n relationship, so we're not tied anymore to the one-one relationship. So we can have one cluster that is that has several targets for backups, and once again we can always do this cross relationship too. So that's a real enabler. We also implemented the delayed replication, which can be configured and also gives you a little bit of time frame if you have unwanted changes on a particular image. So, because all the changes you do on a particular image are always replicated to the other side. Obviously, it's synchronous, so you're always a few seconds behind. But if it's an undesired transactions, then you can revert it before it gets replicated. And for Mimic, which will be the next Ceph stable version, so we just released the first RC this month, and we hope to get a stable release pretty soon. And in this next version, we're going to have the real support for active-active replication. So you will be able to chain as many RBD mirror daemons as you want, and they all will be active, and they will be responsible for a particular chunk of a particular image. So the way we do it now is some kind of a simple scheduler where we have a really naive approach, and we take a particular chunk, we divide chunks for images across n daemons, and that's how you have a particular daemon responsible for replicating a particular chunk of a particular image. This will be integrated into the new Ceph Manager dashboard, the new version of the Manager dashboard, so you'll be able to see what's going on. We also implemented the delete deletion, which can be also really useful as the delayed replication. In this case, since once again everything is replicated, on the primary side, you can do something like delete the image. And if you delete the image, then that will delete the image on the other side. So this will just allow you to revert the transaction once again and just do not do this like restore or something. And the final thing we implemented, this might sound like nothing, but it's definitely a real enabler. It's the ability to clone non-primary images. By default, when we were running non-primary images, so the images that were being replicated from the primary site, we couldn't clone them because they were locked and protected, so there was nothing you could do with them. But if you run a multisite environment with several OpenStack, then you obviously have several Glen store, and then if you replicate all of the images, then they will have to be consumed. So let's take the simple example of this. You have the active cluster and you have passive clusters, and they all represent a particular OpenStack environment. In this case, you have the active cluster that has the initial image, and then all the glance images gets replicated to all the locations. Now what you can do is you can use those images so they can be booted onto the other environments, and this was not possible before that. So when you start doing multi-site, this is something big. This is basically summarizing a little bit everything we described with a particular cluster that does a particular cluster responsible for storing images, so it's cluster 1, and we have a cluster for DR. So it's just basically summarizing everything I said. And now I will leave the floor to Sean.
Thank you, Sebastian.
Thank you.
I hope you can hear me. All right, so you see how every release we're getting new features, right? And some of them are fundamental, right? The last one is key because we really need that image to be synchronized at the edge or whatever case site will be to even make use of it. Now, and you saw some of the features are human-centric, right? Federico mentioned in the beginning the human errors that can bring a whole cloud for hours and cost tons of money. Delayed replication, right? Or even the delayed delete. If I did as a human an error, and it's not too late, right? I can now undo that, right? So sometimes we're adding safeguards from ourselves, if you will, right? All right, let's talk about, so this is a great innovation that's happening at the Ceph front, but we want to use it in OpenStack, right? And how do we can unlock this new capabilities in OpenStack? So that's pretty much where we are. So let's talk about Cinder RBD replication. So Cinder RBD replication obviously is enabled by the RBD driver. But before that, let's talk about where we are in Cinder replication in general. And this is not something unique only to Ceph. It's basically every backend that would like to use Cinder replication. So we started the journey with Cinder replication back in Icehouse release pretty much. And we got all the way to the point where we can do successful failovers using the API. That's great, right? But we're missing key things. What happens if we want to do failback properly or promote? Or move from secondary to a third side, right? All the other capabilities. So as you saw in the previous slide, first of all, from an OpenStack perspective, we want to deploy RBD mirroring. What's the first thing we need? We need to be aware of the daemons, where do we want to place them? So starting Queen's release, we just finished it, right? You can now use OOO to deploy the daemons. You can be, all right, if you know this site is going to be part of RBD mirroring, you can now specify, I want this node to be deployed with a daemon. So we basically have a roles for a multisite built in OpenStack now using OOO. Replication has been done at the previous states of Cinder replication at the pool level. Now we got to a granularity, we can actually do it at the volume level based on a volume type. So you can actually specify as a backend if it supports replication or not. And Cinder assumed basically that the Ceph cluster mirroring is configured and functioning. So we need to have that deployment first line, right? So first of all, the daemons need to be ready for it to work, which is a given, right? And the underlying configuration can be mirrored to multiple sites. So Cinder can actually be configured to reflect that whatever you saw that's available in Ceph to several failover targets. So it's not just site A to site B. I can define as much as targets I want. And as you see, Ceph actually allows you to do it. So as you design your, not just failure domains, as Sebastian mentioned, all the way from pods or whatever unit you choose, you also need to understand where do you need, first of all, the data to live, and how's your protection plan going to look like. And as you see, you have all the options, but it's up to you to design it properly, right? And a few changes we've done on the Cinder runtime configuration, basically to basically do the promotion. So let's say I had a failover to that. Now the primary site is gone. I mean, I'm site B, right? Guess what? I've rebuilt that building that fell up, right, in the first slide. Now I want to promote back. I need to be able to do it in the API level. So one of the things that you saw that's coming up in Ceph is the ability to do active-active replication. We would like to expose that as well, right? So where we are today, and when I say today is basically starting Okata release. RBD Cinder driver basically allows you, as I mentioned, to not just based on the pool, but also as a volume type. So you have the granularity of a specific volume. So if you have a VM, right, with set of volume associated with it, you can protect that VM with its sets of volume. You don't have to replicate the whole pool, all right? It's not, you have very, very specific granularity. Why is this important? You may have on your primary site a pool which is all SSDs, right? Do you need SSDs on the target site? Or you can use spindle disk, right? So you can actually, when you design your replication target, be more granular and actually choose different pools, right? With different cost. So that's another thing you can take into consideration. The RBD driver enables replication per volume, so we mentioned that. Now we actually support multiple mirroring clusters. So before we had also the relationship of 1-to-1, right? So that's something we solved. So after failing back A, this is the limitation you have since Mitaka all the way to Queens. You don't have the fail back capabilities, right? So we're in Rocky already. And I'm happy to say that our focus in Rocky release was actually exactly this, adding the support to promote a failed over backend. So Cinder, API, programmable, can once this is finally merged and it's in upstream review, so you can join the reviews, help us actually to finish this important milestone, right? By having failback and promotion, we complete the journey that we started, right? So it took us all the way from Icehouse to Rocky to deliver this. So yes, we have a fast scheduling of 6 months release cycle, but it takes a long time to deliver that level. But the good news, it's here. Cinder also provides a failback operation to allow administrator to undo previous failover, right? So remember what I said, the human errors. We need to protect ourselves, so we're adding a lot of features against that. And as I mentioned earlier, we want to add the support for active-active. So as you see, the Mimic release is about just in our release candidate. But here is a perfect example, 2 communities working head-to-head together. By the time you have Mimic release, we're going to ship Rocky. This patch is already merged 2 weeks ago, right? So we're ready, right? So you don't have to wait another 6 months to reuse this and unlock this new capability by Ceph. It's already here. And it allows you basically to configure multiple volumes backends that are all member of the same cluster participating in a replication. All right, what are the gaps? There's always like a fine print, like what is the catch, right? Obviously we still have work to do. And there's some limitations. One of it is Nova. If you have attached volumes, obviously you're doing disruptive stuff as failover, fail back, right? The state is not maintained. And we have introduced a new feature in the community in Cinder in Queens and Nova as well to basically allow you to do multi-attached volume to different hosts, right? But if you're basically the same volume is participating in the mirroring party, it cannot be basically attached or vice versa. Last thing, as I mentioned, this is like just merged 2 weeks ago. Don't use it yet in production. And for a start, if you want to start, look at this, help us put some testing in the CI so we can start testing the promotion failback, right? We already have a good standing testing for the failover, but this is new feature in Ceph, new feature in OpenStack. Yes, as a community, we need to properly test it before we run it in production. All right, so Sebastian talked about the Ceph backups, which exists forever, and also how you can use it with our guest agent. So if you're running a database, you can basically freeze the database and do like a hot backup mode. So even your backup is consistent when you do it Ceph. And obviously, we have a Cinder backend for Glance as well, and we're all good. But if you only have a single cluster and you're doing backups, then the backups are local or from a different cluster. Once we solve the replication, right, and across sites and active-active and one-to-many, right, if you combine these 2 features together, basically you are protected, right? It's not enough to have just replication. Another thing you have to remember about replication, it replicates everything. So if you have a data corruption in your database, if you have a Meltdown, Spectre, whatever, just 2 days ago we found another, right? But any corruption you have on site A will be replicated everywhere. So you have garbage everywhere. It doesn't help you. You also need to have the backups. So how do we combine the 2, right? So Cinder RBD Backups with RBD Mirroring. And this is something that's available already now. Right? It's not magic. It's state of the art that's available today, as we put it. So if something goes wrong, you basically need to reconfigure your Cinder backup to point to the mirror cluster, right? Because my primary is went up in smoke. I need to force detach the volume because the state is no longer there. Restore the backup to a new volume, right? Attach that new volume to the virtual machine. And if it's a boot from volume, you need to reset the state because I said the state is no longer there and start the virtual machine again. Guess what? We have our the data is already there. we can basically reuse the backup. Now, there's some best practices around it. Cinder Backup is one of the only services in OpenStack that actually has awareness of itself. And it's ready for this crazy situation, right? What it means, you can actually import and export the metadata of the Cinder service, the Cinder Backup service. So, as Sebastian mentioned, you can have a different OpenStack environment on site bay for all I care, right? It's a different environment, it's a different Cinder. That different Cinder will be able to import your Cinder that went in smoke, right? We build that in. So you have all the capabilities to basically combine the best of two worlds, right? So you have the backups as well as the replication available and ready for any crazy state that you may end up with. Now, this is all 2017. And the reason I mentioned, because as you've seen, some of the themes we've been discussing the whole week here is like the edge and what this brings to the table. So we just talked about sites, right? But where the application lives when we talk about how do, and what do we do, and how do we protect the edge in this new realm. So before we go to how do we protect the edge, let's explain what is the edge, at least in the context of some of our users, mainly at the telco front. Not a lot of change in terms of the needs, because you still need compute, you still need storage, and you need networking at the far edge corners. But the edge sites is basically hosting content for a low latency delivery. And as you can see, the primary data center is different. So we're not longer just talking about failover domains between primary and secondary data center. Now we basically have these new boxes that are at the far edge that maybe can run only compute nodes, right? And with minimum storage, minimum network. I heard today in one of the glance session, one network cable that one of the telco provider mentioned. The remote pods are basically running virtual function. What's a virtual function? The NFV, basically. It used to be a firewall, a switch, a DNS, a box, right? So that box needs to be connected to the centralized data center. And the centralized data center can be, for that matter, the remote POP, which is regional, or it can be the main, like all the way down to the core. This basically opens the door for us to support Internet of Things, IoT, right? So the edge is not just telco, the edge is basically edge computing, right? If I want to run a specific workloads, that can be a VM or a container running at the edge, right? What are the requirements I have supporting it? So I like the slides because it actually shows you where the VNF, where the functions, where the workloads lives in an edge world, right? So the middle is pretty much the customer premise, and as you can see, as we go to the distributed model of what we call distributed NFV infrastructure, is that the VNFs that actually can push all the way close to the customer side. We call it the last mile, right? It can be either the customer premise or the antenna, for that matter, right? Or the autonomous car in the future, right? Basically, we're opening and connecting our cloud to the edge deployments. So, what does it mean from deployment? First of all, do we need to change how we deploy OpenStack? Is it the same OpenStack? Yes, it is the same OpenStack. And guess what? Starting Newton release, now 000 has the awareness to deploy what we call distributed compute nodes architecture. And basically you have a centralized control plane. It's one big OpenStack deployment with a centralized control plane, and then connected to a lot of small sites, right? As you can see, it can be RS, basically a compute node at the edge. And that compute node basically is connected, guess what, to a Ceph cluster. So everything you saw in the previous slides about sites, now you need to translate into this new deployment model, right? It's the same OpenStack that needs to solve the new generation problems. So if you look at the protecting of virtual network functions at the edge, right? So there's some new consideration that were not there before. For example, performance, right? Latency, I mentioned that. So think about what it means for you even to provide service from a centralized site to an edge, right? You need your application with all this long network latency, right? But if you're moving your edge or POP very close, you get service, almost local service. You're eliminating that problem, right? So there's a lot of benefits of servicing locally. And in fact, one of the things we're seeing is this use case open up all of the other use cases I mentioned earlier, which is the IoT and all of them. Because I need to be able to have that image. So Sebastian mentioned the glance image, right? So I want to have that image available, and I'm pushing it all the way from a centralized configuration, a centralized site, to the edge. And I may have changes to my virtual functions. I have a new version that I want to push, right? So what are the things that need to happen under the covers? First of all, replication needs to take place, right? The volumes need to replicate it, the images need to be available, and I need to be able to actually refresh them or use them from cache or whatever the case may be. And we have a slide regarding glance. But look at all of what it means from all the services we have. So for example, in a distributed NFVI, Ceph storage is basically used for both the stateless VNFs that requires ephemeral storage, Cinder with the stateless VNF that require persistent storage, Glance, as I mentioned, that basically needs to now live in a compute zone so it can spawn up quickly from, ideally from the cache. And you don't want to rely on the image transfer delay, right? Because that's another problem. And obviously you want to leverage the copy of write capability that Ceph brings to the table. So, going fast forward from the previous slide, we showed you about the replication between sites. Now we have a new model. We have a centralized site for basically this is the OpenStack controller sits. And we have remote sites that are very small. So think about it in our world like it can be availability zones, right? Where Ceph have that capabilities, but now you can actually set up different relationships. So for example, if I'm designing my application to be serviced at the edge, and one of the edge boxes dies, you still need to fail over, right? And that failover basically available. You don't fail over in the sense that you need to fail over from one edge box to another because it's already replicated, right? And we're building this awareness into the services to basically use them. So it's a different model of, it's not classic disaster recovery, it's basically service, right? We want to build resilience service, application workload services throughout the stack. Distributed NFV is also requiring from, when we look at Glance specifically. So there's several approaches, what do we need in terms of requirements. So we need the support for multi-backend, multiple Ceph cluster. So right now, the deployment needs to be able to support more than one Ceph cluster. So I need to use the same deployment to be able to, hey, I need now to deploy Ceph in each one of these new deployment models, as I showcased in the previous slides. The storage nodes, in each compute nodes, right, without having to use additional physical servers. So we already introduced the ability to do co-location. You can run Ceph OSDs on Nova Compute, basically in a hyper-converged fashion. But what we're seeing at the edge is additional requirement to run everything, right? So because it's such a small box, I want to run my Ceph Mons, Ceph OSDs, right, everything co-located on the Nova Compute, because guess what? It's one compute, right? And typically what we're seeing is just one function running there. The benefits, reduced hardware footprint, so we already have a centralized control plane. We're bringing the ability to manage multiple Ceph cluster from a central control and more resilience at the multiple availability zones. So protecting the edge from an image perspective. So Sebastian talked about the ability to clone images. There's some of this is the more cutting edge innovation that's happening now in Rocky. The first one is a new project, basically using a third-party proxy, and the kudos are thanks for MOD, Massachusetts Open Cloud. The mix-match project basically combines resources across federated OpenStack deployments, right? And it allows you to forward REST API requests to a remote service that basically we're using the Keystone Federation, SAML authentication, etc. And the proxy basically learned the authentication resources based on and it can forward the request. So this approach is basically allow us to use basically support the glance across the different footprints, but it doesn't provide us the granularity of the localization. So for example, I want to push only the specific glance image to that specific edge, right, box. I don't have that capabilities with this, but it's actually available today. It's one of the new projects. It's not yet in even a big tent, so it's very, very new. and obviously we need to test it as a community. And there's another approach which is being worked on right now that we introduced in Rocky, which is called multi-backend for Glance. It basically allows the ability to Glance to have different storage backends, and it opens the door to a handful of image replications and backend targeting use cases. Right? It allows Glance metadata to manage location awareness in different storage backends. Now, one of the things it doesn't do, it doesn't deal with the replication itself, right? Glance mission statement is not to deal with replication. We had a tool called Glance Replicated like a few years ago based on RSig, believe it or not. This is not what we carved it doing. And this is not the mission statement of Glance. Instead, Glance would like to use the best state-of-the-art replication capabilities, for example, Ceph. So if you have already Ceph doing all the heavy lifting of replication, why do we need to solve yet another problem? It's already solved. The only thing we need to care about is building the logic of the image locations, and so we can pull it. So it allows to specify specific Glance backend at the edge. For example, I have a CDN, a content delivery network, a specific image that I want to push. I can actually specify this even VNF image to a specific edge box, right? This gives us much more granularity. And obviously, this needs a lot of work because it's just started during the stain release. And basically, we need also the store driver, the different store drivers to interact with Glance. Glance also added in the previous cycle the ability to have a Cinder backend, right? So if you have a Cinder backend for Glance, also that's another thing that we need to look into. All right, with that, we finished the block piece, and let's talk about some objects. So this is a new addition. Until now, we covered in this talks typically what we're doing on the block level, and we kind of left behind the object piece. And I would like to invite back Federico to show us what you can do in object.
Thank you, Sean. So we haven't spoken too much about it, so it's time to take a little bit of the covers off of what we plan to do here. So this is the active-active object replication, or as it's called in Red Hat marketing, the global clusters function. This is something that's been around since the Kraken release. And since Kraken, Ceph has allowed each object gateway to work in active-active zone configurations, so nothing too surprising there. The way it works is that we allow for writes to non-master zones. Most metadata operations, like creating, deleting a bucket, changing permissions, have to go to the master zone. But all other operations, specifically creating objects, can go to any RGW. And so you wind up with a single namespace spread across multiple clusters, and you can use it for a variety of purposes. Content distribution is a common one. To purists, it's more appropriate to call this a content distribution mechanism than a single namespace, but you get the idea. So what's coming up here? This is important in the context of our roadmap. So the aim that we have here in the context of disaster recovery, in the context of our talk, is for RGW to provide private to public object replication, to either back up to public cloud or to migrate data to cold storage. Our end goal is to provide archiving and tiering to cloud. The target is obviously Amazon AWS. We will start with what we call archive functionality. Based on a policy set on a bucket, the data would be then migrated according to a simple time-based policy. As data ages, can be retired to a remote site, the public cloud. Initially, retrieval would be manual. You would have to go and copy the data back, copy the objects back yourself if you need them. The next step in this progression is what we will be referring to as tiering. Based on I/O access patterns set on object or bucket basis, the data would be moved to the cloud. Then if the data is accessed, the data would be moved back. Obviously, the first access would be slower. As the data, and the idea, at least currently, is to do this synchronously. So your first access would not fail. It would just lag for a while the data is coming back. Obviously, if the lag was so long, it would be a try again, and then you would retry the request, and the data would have migrated at that point. And then subsequent access would be obviously back to normal performance as the data is back in the high performance tier. What is in Mimic right now is what we call cloud sync. It makes a second copy of your data to AWS, but there is no policy support. You can effectively use this as a disaster recovery approach, an additional one besides the ones we have already discussed. Effectively have two copies of your data, one in your local cluster, then the synchronized remote copy. Our plan is to graduate to archive in the next release, which would have time-based policies, as I discussed. And then in a future release that's not being defined yet, we would have the actual tiering functionality based on the hotness of the data. This is very roadmappy. There could be some variation. There is still discussion in terms of how this actually will be implemented in the blueprints. But this is the vision that we have right now of how things will work. In the first stage, the cloud sync is there. The archive and tiering are not. So stay tuned. There will be more coming on this. What about our block plans? So Sebastian detailed the history of this already. We added HA to RBD Mirror with the Luminous release last year, and similarly added triple automation to OpenStack for OpenStack out-of-the-box deployment. The upstream project also shipped one-to-many replication in that version, although that requires replication to be one-directional if you are using one-to-many. If you are doing one-to-one, it's possible to do cross-replication for different images. Obviously, this is block, so you cannot have active-active. Only one place can be active. But different images can be active in different clusters and be replicating their backups across, which, if you analyze the performance of how live cross-site RBD mirroring works, often may make sense. Mimic adds active-active failover between RBD mirror daemons. This version uses a naive balancing algorithm that just looks at how many images are being mirrored and how many daemons you have active, and just does the math and gives you an even number per daemon. The future plan here is to implement a more adaptive load balancing scheme so that the images that have more activity have more dedicated capacity on a daemon, and it's not just an arbitrary number of images thing. It's more of how much work is there to be done. Now Sean will wrap it all up for us.
All right. Thank you. So we saw all the evolution, basically, how we got to this point, including some of the roadmaps, what we're doing both in object and block. But it's time to put it all together, right? So I call it the cloud meltdown A3, right? It can happen anywhere to anywhere, anytime. So you've seen the slides. It can happen. If it can happen to AWS, believe what, it can happen to OpenStack as well. You need to build up your protection plan or your insurance plan, how you want to call it, now, right? Don't wait. And snapshots are not DR, or not even backup for that matter. The good news, it's preventable. We have different failure domains, as you saw, from all the way from snaps to backups to combined with block and object replications. The secret is both design your apps high availability properly across the footprints, as well as the OpenStack and Ceph, right? Distributed your data using the latest Cinder replication with Ceph Block and Object Replication. It's all available, as you saw today. And you can extend the RBD backups with for DR with replication. So don't rely just on one of them. Have the if it's not available in additional site and your site is gone, then you don't have a real backup. Use Ceph to protect your edge, right? We're seeing how the same technology now enable us to basically extend and add more use cases as we need for protection, right? And even a smaller use cases. But again, the idea is to move all of it together, just like Ceph and OpenStack as communities work together. We need to make sure that all of the other services, if it's Keystone, Nova, basically involves in as moving forward together. And the key point is automate and test it, right? It's not enough to have it in place. Fail fast, right? We're adding a lot of scripts basically to do the failover and test it, right? If you don't test it regularly, nobody provides you the application. So replication can succeed, but as I said, you may have a data corruption. You're not aware of it. And so this is something you need to build into and automate to your process. And yeah, if you do it, basically all of this, you're getting one step closer to protect your cloud users. And next time a failure happens, they may have some slowness to get their service, but because one side or two went down, but you're not out of business, right? You're still going, applications still running, and the secret is this is happening in advance. Your data is being replicated in advance. Your images are being cached in advance, right? Yeah, so any application has basically the ability to run in all of the other footprints, basically. So that's it. So with that, we'll take some questions. I know that we're out of time, but all of us are here to answer. Yes, go ahead. Use the microphone, please.
So if you've got like 2 Ceph systems in a total DR situation with 3x replication on both systems, you're down to like 1/6 of your capacity is usable storage and the rest is all redundancy. So my question is, with the existence of a DR, like with the existence of a duplicate system on another site,
Yes.
does it make sense to rethink your replication factor?
Absolutely. And what we've seen from customer is actually using that additional site for different purposes, right? So one of the things we enable is the cross-replication. So one of the protection policies, believe it or not, is the cross-replication. So both of them are active, both of them are working. You're not putting resources just for the sake of backup. And you don't know where the fail is going to happen. It's either site B or site A. It doesn't matter because you're doing cross-replication between the two. So we are utilizing the clusters and not just for backup.
So 2x replication then, or like what would you?
Depends, right? The point is what application you're protecting. And it's go back to what Federico said about the RPRTO. How fast do you need to recover? And the 2 or 3 is, again, depends on, sometimes it's even the application requirements. So, right. The more stateless it is, then yes, you need less.
Thank you.
Yeah, come again. Come to the stage. So. Okay. I can give you mine.
The way I would think of this.
Can you open the mics? We're out of.
We're done.